Hello everyone, welcome to tutorial 4 of ECON1310. It will be the second tutorial on probability, and let's start with the everything admin. So first, CML1. The second attempt is still open, and it will be open until tomorrow 4 p.m. So if you're still doing planning to do, or you have started your CML1, make sure you submit before 4 p.m. tomorrow. Otherwise, you're gonna miss this attempt. I would suggest, unless you have got, if you got like full marks for your first attempt, it's always a good idea to do the second attempt, because we will consider the highest score. So why not practice a little bit more and increase your your grade? Even if you got the highest mark and you want to challenge yourself, it's a good idea to do. CML2 is also open. As you know, the first attempt takes a little bit longer. It's open for a little bit longer, and we encourage students to try with a friend if they want for CML. And discuss. A lot of times the questions, most of the time, the questions won't be the same. So one can help the other. So for CML2, first attempt, I've seen that some people started, a couple of people have finished already the first attempt, and it goes until Monday, okay? Also, make sure you submit. Any question about CML? Let me have a look in chat. I think CML now, it's already the second attempt, and CML2, you guys might be getting used to how it works, right? All right, very important now, I would say even more important than CML is the LBRT. The LBRT is a little bit different. LBRT, you can't do with another person, you must do by yourself, and it's pretty quick. Although you have a whole day to do it, like more than a day, as you will see, from the 3rd of January, first week of 2023, actually the first Monday, if I'm not mistaken, sorry, Tuesday. So probably you have a chance to chat with us. There will be a consultation. Let me see. No, I think we're back on the 3rd, so there shouldn't be a consultation before. Have a look. But definitely during your LBRT 1. So you have from the 3rd of January until the 4th of January, the Wednesday. I want to double check that once again. Yeah, Tuesday and Wednesday. But the thing is, you have only 90 minutes for the LBRT. It's not, you don't have the whole day like the CML. It's just 90 minutes. And when the time's up, the time's up. So make sure you can do things with time. Try to do all questions, then come back and check to make sure you did everything all right. You will also have a second attempt for the LBRTs. So don't need to be too nervous about it, but it's good to be prepared, because although CMLs will be worth 8% each, the LBRTs, it's worth 20%. So it's pretty important. There will be just 3. All of them will count, and in total, they will count for 60% of your grade, 20% each. All 3 LBRTs will have attempt 1 and attempt 2. So good luck with it if I don't see you before you attempt your LBRT. And the lectures covered will be from lecture 1 until lecture 4. So everything we saw until today. Do you guys have any questions about LBRT? I would like to see, we have 26 people. I want to make sure everybody knows when the LBRT opens. Can you guys write on me on chat when the LBRT starts, the day? Just the day is enough. but I would like to see all 26 writing down in the chat. Nice, good job. I can see 3. Very good. Yeah, it's not a difficult question. It's not a trick question. Amazing. You can see more than 6, 7, 8. Nice. A few more, guys. Let's try to have everyone. Can you guys please jump in and chat just to make sure you know exactly when it opens? Amazing. I don't know how many we have. 3, 6, 9, 12. A few more. You guys still there? All right, that's good enough. What else? Just quickly, I'll pass by. I noticed from very good job, guys, with the answers. I noticed for last week, we have had one more student, and with time, it was a little bit shorter tutorial. So the maximum we had was 9.5. I was here for a little bit longer. The minimum 23 minutes, and mean time, standard deviation, etc. Still pretty good. But the thing that I would like to call attention is that I noticed that maybe the questions in the poll started getting a little bit trickier, a little bit more difficult. And I noticed not everybody answered all the questions. Did you guys feel, can I get a thumbs up if you felt that the questions were harder during tutorial 3 than 1 and 2? If not, you don't need to answer anything. But if you felt it was a little bit hard, I would like to give a thumbs up or something. No? Still all right? Okay. Yeah. All right, yeah. I would think that from the idea with the course is for the difficulty to be progressing, right? So we might have, maybe it will be a little bit more challenging, the questions, but I'll try to give you guys time to answer it. And don't be afraid of trying out, or if you're not sure, it's more important to participate than to get the answer correctly. It doesn't mean, but if you can, please put some effort and try to get the right one. But let's go. All right. Let's go for tutorial 4. So at the end of this tutorial, you should be able to construct a discrete probability table, probability distribution. It's just a table, kind of, we can call it a table or a matrix with the probability distribution. Calculate the mean and variance for a discrete probability distribution. Describe the characteristics of a binomial distribution, and calculate the probability of a particular outcome of a binomial distribution using a calculator. All right, as you notice, our calculator in this tutorial will be the Excel. So we won't be using a lot of the calculator itself. Excel will be enough. I hope you guys have a chance to install and play a little bit with Excel in your computer. If you couldn't, please email Dominic if you don't know how to install, and maybe he can share a tutorial or something, right? Okay, let's start first with the first question here. The number of car radios sold each week by a large company has been recorded for the last 100 weeks, right? No radio has been sold in 3 of the weeks. 1 radio has been sold in 20 of the weeks. 2 radios in 50 of the weeks. 3 radios in 20 of the weeks. 4 in 5 of the weeks, and 5 in 2 of the weeks, right? No more than 5 radios were sold in any of the past 100 weeks. So here we have all of the options, right? It would be either from 0 until 5 radios being sold, no more than 5. Construct a probability distribution for the number of car radios sold in a week using the relative frequencies as probabilities. in the long run, what is the average and standard deviation of the number of car radios sold per week? So let's jump to Excel. What I did here was X is the value of the amount of radios that we sold, right? So what do we have? For 0 radios, they said how many? No radios have been sold in 3 of the weeks. Look, 3 out of how many weeks? Can someone put on the chat how many weeks we had in total? Amazing, thank you, Noah. So 3 out of 100. Because when we're talking about probability, we want to have in total a 1 as a total probability. So we are going to say equals 3 divided by 100, which is 0.03, right? And the same thing for the rest. I think I'll just, no, same thing for the rest of our table. Let's go. Our probability distribution. 1 radio in 20 weeks. So 1 radio in 20 weeks, 0.2. I'll put it here, 20 out of 100. 2 radios in 50 weeks equals 50 divided by 100, 0.5. I'll just put it here for reference. 50 divided by 100. 3 in 20. Oh, sorry, 3 radios, 20 weeks out of 100. You will notice sometimes if you get the numbers together, you might get confused. You can see like, I just put something wrong. Yeah. So 20 weeks out of 100, right? So 3 in 20. 4 radios sold in 5 of the weeks. 4 radios in 5 of the weeks. 100. Finally, 5 radios sold in 2 of the weeks. 2 out of 100 weeks. If we add up, look here how cool it is. Sum to 1, right? So now it's your chance. We have there, and I'm going to put the poll. So let's see if we can calculate the mean or average of radios sold per week. Let's go, question 1, launch. And I'll give you like maybe 2 minutes to calculate how many have we sold. So we're looking for, let me annotate what color. Today we're looking for this one. We are looking for the average at the moment of car radios sold per week. Oh, my computer just froze. Oh my God, sorry. Of cars sold per week. Seems like my computer is having too much at the moment. I have 7 answers at the moment. 9. Yeah, and let me bring back while you guys are calculating. I will bring back maybe an advice. You see, we have here an explanation of the expected weekly sales radio or expected amount. We're talking about the mean. And look, here we have a formula. The expected value or mean of a discrete random variable probability distribution. You will see here for discrete, and then mu is equals to the expectation of x, which is equals to the sum of the amount here, in this case 0, 1, 2, 3, 4, 5, times the probability. So we get these guys. Basically, we're multiplying and then adding everybody. Here's your advice for this question. I have 15 answers up to now. We are 26, so I'm expecting up to 25 answers. We are 18 at the moment. Let's see, guys. I'm missing just 7 of you there. 6. 10 more seconds. And then I want to share the results. Just missing 5. And that's about it. Finish sharing the results with you guys. So have a look there. I can see a lot of people went for the 2.5 here. 50% of you, 10 out of 20 answers. And I don't know if you guys kind of got the half of the 5, but look how it works. Let's go back to our Excel. So this is the straight from the slides. And what we're going to do for the mean value, oops, I need to clear my annotations, my drawings. The mean value, the probability of each thing happening will influence the mean in the end. So look what we have. It would be 0 times 0.03. The same thing if I drag it to the next cell, you will see that it's 1 times 0.2, right? I'll drag it to the end. Now that we have all of them, here I can just sum, auto sum. And this is the answer. It might be a little bit surprising for some of you. I don't know. But look how, do you guys have any question? I can see half of, I think just a few of you got this one, right? Any question at the moment? Feel free to open your mic or type down. And in case you're typing down, I want to put the rationale here. If I told you that every week we sold 4 radios, look how it would change. So every week we sold 4 radios. 0, 0, 0, 0, 0. Look at that. Makes sense, right? Like the average was 4 because every week was 4. So I wouldn't expect anything else other than that. And I'll undo this thing. Or let's say 50% of the days were 2 and 50% were 4. Then 0 for the other ones. You're probably expecting a 3 there. And look how it works. How nice. And that's a little bit how it works. So the weight of each of the options, you have each of the outcomes, right? It's important. So that's why we call it a weighted average. So 2.1. Is it clear? Can I get a thumbs up? A few thumbs up, please. You guys still there? Nice, nice. Thank you. Amazing. All right. So this was the mean. And from the mean we're going to go with the variance. And there is also a formula for the variance that you'll see on the slides. Look at it here. Variance, we call this little symbol here, it's called sigma. And the variance is sigma squared, and the standard deviation, which is the square root of the variance, is just sigma. So standard deviation will be sigma, variance is sigma squared, sigma to the power of 2. And they are asking us the standard deviation. So we will calculate the variance, and then from that we take the square root and we get the standard deviation, right? So how do we calculate it? Look, it's the sum. So like before, we will have a sum like this, right? And what is inside? We have the difference. Let's see, there's a question. Yes, Harry, it is. But then as if you've seen it before, probably you have to use the integral to calculate that. But yes, that's how it works. In this case, it will be more like a sum because it's a discrete variable. But we don't cover this in this course. But yes, it's also that way to calculate. Let's go. So here it's the difference between the mean and the outcomes that we had, right? The observations. And then this will be squared, and then we're going to times it by the probability. So it's also a weighted average. So we're going to multiply by the probability. I hope it makes sense. Let's try to do the let's go for the first one then. Equals to, what is the x for the first one? X is 0 minus, what is the mean that we found was 2.1. Okay, these I want to put in brackets because we're going to square it. So in Excel, we're just putting the little hat and 2. And then after squaring, we're going to multiply by the probability. So now multiply by this guy. Feel free, if you feel like you need, you can add more brackets to make sure things happen in the order you want. But I'm a little bit used, so I'm saving a little bit of the brackets. You definitely don't want to do this, right? Because it will be a very different thing. You're putting this one squared, and that's not what you want. We want this guy to be here. So this is a squared. Why would you want another one? So let's get the value 1 minus the mean. And you don't really need to worry about if the difference, Excel might not like you doing things in order. But yeah, put inside of the brackets, and when you square, it becomes positive, right? Times the probability. If I drag down the way I did, look what's going to happen. This is nice, this is nice, this is not nice. So these two guys slide down, but this is like that. I don't want it to happen. Look what I'm going to do now. I'm going to fix this. Which one do I want in place? This color here. So F8, I'll press F4. Look at what happened there. This means when I drag down, it will still hold the same guy. This is very useful in Excel. Now, if I drag to the next cell, these two guys move down, but this guy is still there. Look, this same line, this same line, and this is that. Okay, so basically drag into the rest of them. That's what we get. And now I will just sum everybody. And this is what we get, 0.89. So this would be our variance. Let me see, I hope 2.1, I hope we're right, 0.89. Finally, does anybody know how to do square root in Excel? Can I get it in the chat or voice? Open the mic. Amazing, thank you. Yeah, you start with an equals square root. You will see the little function here. of which value? This one we want, right? Enter. So 9434. I hope you guys are not surprised that the square root's bigger than the variance. It happens when the number inside of the square root is smaller than 1, right? And so, yep, that's the standard deviation. Now click one more, and this is it for this question. Any question? Do you want to have anything you would like explained more in detail? I'll start moving. If you guys typing, feel free to type on chat or open your mic if you have any question. But I'll start get going. A travel company, question 2. A travel company is considering introducing a new package tour. Based on market research, if sales are high, they can make a profit of $107,000 per year on the new route. Moderate sales would mean they can make $35,000, whereas poor sales would imply a loss. Pay attention to the loss of $37,000 per year. If the probabilities for the profit scenarios are 0.57 and 0.31 respectively, determine the expected profit, determine the standard deviation of profit. I have a poll for this one for you guys to calculate the stop sharing. To calculate this mean. I'm launching it. So determine the expected profit, and a little bit of advice for you once again. Expected is the mu that we saw before. So it's the same formula we used in the previous exercise. So you could draw the little table with each of the outcomes. There are 3 outcomes. I'll give you 3 minutes to solve this one. Let me look at my Excel. I hope I deleted. Did I delete? No, I won't click just yet, because I might be giving out something. I have 6 answers at the moment. So 7 answers. So let's go. A travel company is considering introducing a new package tour. Based on market research, if sales are high, they can make a profit of $107,000 per year on the new route. Moderate sales would mean they can make $35,000, whereas poor sale would imply a loss of $37,000 per year. If by any chance you don't know the difference, when you do a loss, it's a negative profit, if you want to call it that way. So you either make a profit or you make a loss. Profit means your revenue is bigger than your expenses. A loss means your expenses are bigger than your revenue. I have 12 answers at the moment. Still a lot of people to do. 13. I'll give you another minute. And the process is pretty much the same. So let's have a look how we did for the question before I move to the next one. Basically, look at each of the outcomes, look at the probability of them happening, and I will give you an advice here. They have to add to 1 the probabilities. This might give you a little bit of a hand when calculating this. And pretty much what you're doing is this here. You can see 15 answers. 16, missing just 8. Another five seconds, maybe. 18. Good. We'll stop at 19. Amazing. Good. I'll share results. And yeah, seems like almost half of you got this one. Let's do it together then. Share results. Okay, so once again, the first one was 107 in profit. 107. The second outcome is 35. The third one was a loss of 37. So if it's a loss, we're going to do this, minus 37. And then they say, if the probabilities for the profit scenarios, profit, so just when it profits, probably it's not the loss, 0.57, 0.31 respectively. So 0.57, as they said, respectively, where is it? Respectively. Then it means in order, right? Ooh. I switched the screen so much I forgot. Okay, 57, 31, 0.31. What is missing here? So we know the probability has to be 1. Right? Let me move this one down a little bit. This is equals 1 minus this guy minus this guy. So you probably got 0.12 there. And now this times this. I will drag it down. We have all three of them. Now I'll click out to sum. Look what we have there, 67.4. And we had 9 people got it right. Congratulations. And for the ones who didn't, this is how we do. So it's important to pay attention. There's a negative there. It's a loss instead of a profit. And pretty much the same process. A sum of the outcome times the probability added up together to this guy. Let me put a little dash here. Same thing. Now they asked us. So I'll click and click 67.4. Now we have determined the standard deviation of profit. Let's go there again. Equals to this guy minus, so it's a sum of this guy, the x minus the mean, the mu here. Now I'll press F4 to lock, and I'll close the bracket. Now I'll come to the beginning. I always forget to open the bracket in the beginning. Put it squared, and then times the probability. Big numbers now. There you go. Sum. This is the variance. Finally, here, square root of the variance to find the standard deviation. I hope it was right. Well, just an advice here. I added, so standard deviation of x is the sigma equals to the square root of sigma square, as you guys already know, right? Which is the square root of the variance. And basically what we found was 2,527.2 for the variance. These are thousands of dollars squared, because we're talking about thousands of dollars here. These are thousands of dollars squared. And then the standard deviation is $50.27,000. Square root, $1,000. Okay. Any question for this one? I think doing the, feel free to write down in chat or open your mic. Doing this probability table, makes it really easy to understand what's going on. This, do you know why we call it discrete? Does anyone want to type on chat or open your mic to say why is it discrete? Probability and not continuous. Let's see, I'll look at chat. Why is it discrete probability? Only three possibilities. Yeah. So it is discrete because they will give you, can only accept certain values. Yes, good. They will have the certain values, and in between them, that the point in the middle of those or anything in between is not accepted. Most of the times, the discrete probability will be, for example, integer numbers. You'll see it a lot. For example, if you roll a die 5 times, you can get 1, 6, 2, 6, 3, 6, but you can't get 3.5, 6, because you either get it or you don't, for example. And we will be talking about it, about the binomial distribution, the other on the beginning of the next question. But this is discrete. So there's no, most of the times there's no 3.5. Or in this case, for this exercise, there was 107, there was 35, and there was minus 37, but nothing else. Just this 3. The total of the probabilities was 1, if you add the probability of all those outcomes. So you could say these 3 probabilities, these 3 outcomes are mutually exhaustive. So they take all the 1 probability total, 1, or 100% if you prefer. So let's go. Next question then. Question 3. It was thought that 32% of people prefer Pepsi to Coke. 35 people participated in a Pepsi versus Coke taste test. Each person was given 2 samples and asked to say which they preferred. I prepared a poll just for the first question here. I'll stop sharing. And question 3, yeah, launch. And it's pretty simple. I just want you guys to pick apart each piece of information here to answer, is this a binomial situation? What are the properties of the binomial distributions? So in the questions, I have all the 4 properties, and I want you guys to choose the piece of information which satisfies that property. You will see that the answer for the 4 questions are all the same. It just, each of them will be the answer for the property. All right? We've got the first answer. I know this one looks a little bit longer, but basically there are 4 properties. Are these identical trials? Are there only 2 possible outcomes? What is the next one? Are those trials independent? So independent from each other. I don't know. If you invite maybe a family of people who all drink the same cola, maybe they are not independent. So hopefully they were picked in an independent manner. And is the probability constant? Or what I mean here is the probability the same for every person, or let's say every person interviewee? And I have 9 answers at the moment. So we will have the same quiz in another question, but it's for you guys to get used. I'll give you another minute. It's for you guys to get used to the conditions for you to say if it's a binomial distribution or not. And the rest of the questions, the other 2 will be, what is the expected number of participants preferring Pepsi? And what is the variance of the distribution? I have now 11 answers out of 23 possible. Sure, you can do it. It's a little bit longer, 12 answers. Yeah, another 30 seconds. And it's very interesting that when it's a binomial distribution, you'll see that the expected value and the variance, it's very easy to calculate. It's a simple equation. It is a little bit harder to calculate each of the outcomes, but we will see how to do it today. So 14 answers. We'll close this one. 15. Nice. Good job. 16. Okay. Share results. I can see like it's not super clear. I understand if you thought that some of the questions were a little bit, well, it could be 2 answers. I agree with you. It's not super obvious, but there are some of them that are quite on the nose. It's pretty clear. So I'll start with constant probability, the last one. It's thought that 32% of the people preferred Pepsi. It's missing the Pepsi here. I should have added the word. Sorry for that. So this is quite clear. It's the 32% for a constant probability. It means the people being interviewed, we expect or we thought 32% preferred Pepsi. So it's not that for that person I thought it was 32, but the other one I thought it was 35, right? Okay, let's go to another one. Are these trials independent? I would say we don't have enough information to say that, but I was expecting the answer to be random people participated in this taste test. Then are there 2 possible outcomes? And I see more than half of you got it right. It's either Pepsi or Coke. So these are the only 2 we're testing. And finally, are the trials identical? And I expected this one to be answered. Each person was given 2 samples. So basically 1 Pepsi, 1 Coke. That's what they were given, and they were going to try and everything. So the trials are identical. The people the interviewed people are independent. The trials are independent. And yeah, we have only 2 possible outcomes and constant probability. Oh, I could have clicked. I'll stop sharing the results. So there you go. What we expected, right? So this is a binomial distribution. You either prefer Coke or Pepsi. Let's go to the next one. What is the expected number of participants preferring Pepsi? Click one more. So the expected number, as we saw in the other 2 questions, is equals to mu. And here on Excel, oh, I don't have it in Excel, sorry. It would be written here. Look at how we calculate. It's just the number of trials times the probability, which we have here. We had 35 people times the 32% or 0.32. So we expect 11.2 people to, it's the expected number who prefer of participants who prefer Pepsi. Let me show you where I do have it for the next question. Don't we? No. So I will show you how to find in the lecture slides. Binomial. This binomial. I expect it to be here. Did I pass? Oh no, here it is. The mean number of successes n times p. Pretty nice way of doing it. Look at the variance, how interesting. variance sigma squared is n times p times 1 minus p, which is the next question. It's asking us the standard deviation, right? So variance, which is sigma squared, is equals to n times p times q. And you will see sometimes they're showing q as the probability, and this is just 1 minus p. So if p is the probability of that thing happening, q is the probability of that thing not happening. Or because we're talking about a binomial, there are just two things that can happen. Usually it's a 0 or 1, or it's a yes or no. So either it happens with probability p, or it doesn't happen with probability q. Okay, so I put it there. N times p times q. N is our 35 again. Then the p is our probability here, 32, 0.32. Then q would be 1 minus 0.32 with 0.68, so equals 7.62. The variance is here, 7.62. And finally, I added the standard deviation, which is just the square root, which is 2.76. That is it for question 3. Any question? I understand it might be a little bit harder than the first week, but we go step by step on how to solve these things. How you guys feeling? Is that all right? You guys good? You guys still with me? Maybe a thumbs up. Nice. You can see, amazing. Nice, nice. Yeah, look, it's a good idea to try it back at home. And if you're planning to use Excel, for example, for your LBRT, where you have a limited amount of time to solve things, it's very important for you to be used to it. So try doing things, especially like if you're going to commit a mistake, you want to do it before your LBRT, right? So good luck with it. Let's go back. Question 4. Use your calculator to find binomial. The probability of x equals to 9. Given we have 14 trials. I'll put in a 4 here, it's like 1, 4, maybe. Hope it's the right direction for you guys. And the probability of getting it is 0.4. And then they ask the same thing when x is smaller than 3 and it is equals to 1. Da, 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 da. As you know, our calculator is Excel. I put the same thing in there. And look here how you calculate probabilities when we're working with the binomial formula. So probability of getting, so what is going on here is, I don't think it would be clear for everybody. So a few things happening. So look, understanding the binomial formula, a good way of thinking it is flipping a coin, tossing a coin. Because tossing a coin, you either have head or tails, right? So it's either yes or no, or 1 or 0. There are many ways of thinking about it. But here, what we're doing is we're tossing 14 coins. And we want to know what is the chance that 9 of our tosses comes up with heads, for example. Could be tails, but let's put heads as value 1. And our coin is biased. So there is a 40% chance of getting heads in each of our tosses. I hope that is drawing a little bit what's going on here. So this is how you think about the binomial formula. The way to calculate it, it's like this. Number of tosses is for us will be 14. So out of 14, this C is choose X. X is our 9 for the first thing. So 14 choose 9 times the probability of getting ahead. So 0.4 to the power of how many heads we want. So 9. And then Q is the opposite. It's the probability of not getting a head or the probability of getting tail, which would be 1 minus 0.4, 0.6 to the power of n minus x. So 14 minus 9, which would be 5. Okay. But the good thing, as per usual, is that our friend Excel has a formula for it. So look at that. Binomial distribution. There you go. If I click, returns the individual term binomial distribution probability. Individual term x equals to 4. I'll click. So binom.dist. Number S. So basically, this is what number do we want? We want 9. We want to know the probability of getting 9 of them. Comma. Trials. How many trials did we do? 14. There you go. And then probability of getting that outcome. 0.4. Last thing, and it's very important because we will use a different thing for the next item. Comma, look at that. It's going to offer you either true or false. So if it's true, we're getting the cumulative distribution function. Cumulative would be everything, sorry, I think for you guys will be from this direction, everything until 9. That's not what we want. We only want the probability of getting 9. So we'll put false. Okay. Double click, close my bracket, enter. There you go. That's the number. It's not a lot of chance because look, it's just 4%. But if you pay attention, we have 14 trials and we want specifically 9 outcomes, 9 head. And the chance of getting head is actually 0.4. It's less than half. So it's not surprising that it's a small amount. So it could be 0, could be 1, could be 2. We could be asking until 4, from 0 to 14, right? We ask 9, there's a 4% chance. But look at the other one. So I'll put the formula so that it's visual. Just put it there. This is what we did. And let's go back to the so here I put the same thing. The calculation we did was this one. And there you go. Wow, maybe not yet. Jumping a little bit ahead. Now for this one, look how interesting. X is smaller than 3. So this is where this last part comes in action. So which, can I get in the chat, which options am I allowed for the second one? So we want the probability of X is smaller than 3. Then do I accept 0? Do I accept 1? Do I accept 2? Do I accept 3 and 4? Yeah, good job, Noah. We don't accept 3 because there's no smaller or equals. It's just smaller, less or equals. So 0, 1, and 2. We could do this equals to this, the same thing we did before. Equals to binom dist of 0, 14, 0.4, false. And then I could add the rest of them for 1 and for 2, but this is a little bit too much. Did I do it right? Not sure, but let's see. We could also do it like this. Binomial. Ah, 1 minus x bigger. So usually, Harry, we look We will do it later, you're right, but we look at it in the opposite order. So when it's cumulative, it comes from the smaller number up to that one. So, oops, binom dist. Look, 3, oh no, 2, it's 3 we don't want. 14, 0.4. Good question. I think probably there must be. I can have a look. But usually we tend to play with when you have bigger than, then you put a 1 minus the x. So look, instead of doing false, so we'll do true this time. So returns the cumulative distribution function, which is the probability that there is at most number s of successes. So at most, the number we put here, which is 2. So true. And look, it is about the same. Let me extend. So instead of doing it 3 times, you can just do it like that. And that's it. I will copy. In probability, and statistics, it comes in hand to do this a few times, especially if it's continuous. We might want to look up to a certain point, but it doesn't matter if it's discrete or continuous, both of them. Sometimes you want the cumulative one. So can you see that we could have made a mistake? If you don't pay attention to what's smaller than 3, look how much it changes. It's a pretty different number, right? Just pay attention. This is smaller than 3, so at most 2. That's it. There you go. Any question for question 4 here in our favorite calculator, Excel? Let's go. So we're moving already to the last question of this tutorial. And I will give you a poll, and we're doing the same. Does this situation satisfy all of the binomial properties? Explain, state the parameters. So let's go there. Question 5. Launch. Same thing as we did before. Now, yeah, take your time. I'll give you like 3-4 minutes to do this one. We're very good with time today. So a life insurance salesman has arranged to call on 3 households tomorrow, just 3. Based on past experience, he feels there is a 20% chance of closing a sale on each call, and that the outcome of each call is independent of the others. It means no matter if he closes or not this one, it won't affect the other ones. Sure. Let X represent the number of sales he would close tomorrow. So let me see. Basically, the four parameters that we're looking for a binomial distribution is: are the trials identical? Are there just 2 possible outcomes? Are the trials independent? And is the probability constant? Well, let's see. I have 10 answers at the moment. We have a potential of 24 answers. So yeah, still a lot of people to have a chance to answer. You guys, from what I see, you're doing really well this time. Much better than before, which means you guys are really getting how it works. Good job. $19. Very good. Just 5 people missing, just 4 people missing. That's really good. Last four? Any chance? Another 15 seconds for the last four? So as you can see, most of you are able now to break down the text into why are these four parameters for a binomial property. Sorry, for a binomial distribution, right? Just missing +3. I will end the poll. 22 answers, very good. Just 2 people missed the chance. Look how well you did this time. Good job, very good job. Let's go. So here are the answers. So are the trials identical? Basically, I don't think I made this answer super clear, but like he's going to call the 3 houses tomorrow. It's not super clear, but by elimination, you would get this is the option. So 2 possible outcomes. You can close the sale or not. Trials are independent. The text this time, they made it very clear. The outcome of each call is independent from each other, of the others. And constant probability, 20% chance of closing a sale on each call, also pretty clear. So just by elimination, you would get the first one. Good job, you guys did great. So determine the probability distribution of X. Let me see what I get here. I hope I don't give out the answer. There we go. So the chance of the sales, we're going to do, let's go to Excel. So we're calling 3 houses. We might sell nothing. We might make 1 sale, close 1 sale, close 2, or close all 3 sales, which given the chance of each of them 0.2 seems like a little bit unlikely. Well, let's go. First question, let's do one by one. As we learned before, binomial, dist, number. Let's start with 0. Or for 3 trials only, the probability we saw was 0.2. And this time we're doing 1 by 1. So I'll choose false for cumulative. It's not cumulative, it's just 1. So 0.512. So more than 50% chance of not selling anything tomorrow. Not too good. But now pretty easy. Let's just replace 0 by 1. Another 0, 3, 8, 4. If you're curious, you notice like, whoa, pretty high chance here. 90%, almost 90% of chance that I not sell anything, not close any sale, or just close 1. Okay. Now 2 sales, closing 2 sales. The chance goes down to less than 10%, 0.096. And finally, 3, closing 3 sales, almost impossible, less than 1% chance, 0.008. That would be the salesman lucky day if he did. So that's how we do. Look how quick it is after you have it on Excel already. Look how easy it is to edit a few things. If I would give you an advice, when I did my LBIT, I used Excel. And I had a few things from previous exercises already done there. Saved me some time. So you guys take it as you will. This one. So basically, this is our probability distribution for this salesman. Oh, let's try one thing. Let's see if it adds to 1 equals to the sum of. Can I get a thumbs up if you think it will add to 1? Let's see. Or maybe can I get something else if you think it's not going to add to 1? Thumbs up for 1 or anything else for not 1? I saw just 2 thumbs up. You guys don't wanna risk this one? Okay, all right. So press enter. Yay, we got one. Ooh, this one is very round one. Now let me just put it somehow away from the rest. It's not important. It's just saying that, as you can see, a binomial, we have 3 trials, the number from 0 until 3 of outcomes. So we can get 0 outcomes up to 3. It adds to 1. And that always works like that. Okay. And finally, our last question for today, for this tutorial, find the probability that more than one sale will be closed tomorrow. And we have this one, more than one. So this is the probability of X being bigger than 1. Amazing. Almost there. In this case, look what I'm going to click. I think I added a few advice before the answer. We could say it's also the probability that X is bigger or equals to 2. Or we could say it's equals to 1 minus the probability that X is smaller or equals to 1. So because our question is asking just more than 1, not 1 or more, right? So interpreting these things here, yeah, exactly. That's how it works. You could also, let me think. I think that's enough. There are other ways of putting, we're basically pretty much talking about the same thing, right? I could have said it's 1 minus X is smaller than 2. Not smaller or equal, just smaller than 2. That also works because it's discrete. But let's go. So now we have the X bigger than 1. What we were talking about there is the following. So 1 equals to 1 minus. Now we get to our binomial again. Binomial, dist. And now we're going to do the cumulative distribution. So we're getting both 1 and 0 so in the same. So it's the 1, it's the at most 1. Then the rest is the same. 3 trials, 0.2. Then in this case, we're talking about the cumulative distribution. So I'll click true, close the bracket, and this is what we got. 0.104, 10.4% chance. So is it clear? It's 1 minus this. You could also do a much easier way, just add this to 0.104. But if you had like a massive amount, huge binomial distribution to analyze, you don't want to calculate 1 by 1. This is, let's say, a quicker way, depending. In our case, it took a little bit longer, but this is another way of doing it. So there you go, 1 minus. And this was the last question. Do you guys want to ask anything? Want to open your mic, send something on chat before I end the video? All right. So today we were talking about how to construct a discrete probability distribution. As you saw, when it's discrete, it's easy. We just put the outcomes on a table and then you put the probabilities. Then we discussed how to calculate the mean and variance for a discrete probability distribution. So the mean, once again, we're getting the outcome and multiplying by the probability. Then you add everything. And for the variance, then it's there's a little bit of an equation. It's the square of the difference of the outcome minus the difference of the outcome and the mean times the probability, and then you sum everything. A little bit complicated if I'm saying it, but when you look and when you do it by hand, you see it's not too complicated. It's just a few steps. And then Describe the characteristics of the binomial distribution, which you guys did really well for the last question. Good job. And finally, calculate the probability of a particular outcome of a binomial distribution using a calculator. Guys, thank you so much for participating. For you guys at home, thank you for watching this video. Good luck with your CML2, and good luck with your LBRT if I don't see you at that point. Have a good one. Enjoy your weekend if I don't see you anymore. Another thing, consultations will be still up next week. Next week, we won't have tutorials, but we'll still have consultation. Okay? I'll stop the recording. Have a good one. Enjoy. Bye.